In today's lesson, we will use videos and slides to continue our discussion of geology and the layers of the Earth. We know the basics of the Earth already from previous discussions, but let's review it again. The structure of the Earth can be separated in three different layers: the crust, the mantle, and the core. To begin our discussion, let's watch a video titled "Cracking the Earth's Crust." Here are some essential questions to think about when watching the video. Describe the characteristics of the Earth as experienced by the miners in the video. Explain what causes earthquakes in the video. Explain the conditions of what the researchers title extremophiles and how they survive in the deep layers of the Earth. And finally, explain the two types of crust as defined by the researcher.
We're going on an imaginary subterranean journey around our planet. A remote sensing vehicle will investigate the Earth's crust in close-up. This mysterious layer of rock is all that protects us from the superheated mantle below. It is a fascinating secret world we are only now beginning to understand.
It has been set up like an ancient Egyptian library that we found the door to.
We will uncover the crust's treasures, learn how they get there.
It would be very fast, a crack would open up, it would make Mount St. Helens eruption look like nothing.
Discover how the outer skin of our planet preserves and enriches life on Earth.
We are seeing what we think was the start of life.
And reveal new insights into Earth's largely unknown interior. Tautona Gold Mine, about 70 kilometers southwest of Johannesburg, South Africa. An hour-long descent through solid rock carries the workers to the subterranean gold deposits. At 3.6 kilometers down, this is the furthest man has ever ventured into Earth's crust. This rigid layer of rock, on average 30 kilometers deep beneath continents, covers the surface of our planet. But even just 10% of the way down, the miners are starting to experience the extreme conditions of a hidden world. Down in the bowels of the Earth, it's hot. The miners work at a rock face where temperatures reach up to 58 degrees Celsius. About 2 kilometers deeper, and the rock temperature would climb to around 90 degrees.
That's close to boiling point. The rock itself would scald you, making it totally unbearable.
Crushed beneath 3.6 kilometers of sedimentary rock, the pressure down in the mine is almost 400 kilograms per square centimeter. Working under these intense forces is a lethal business. Every day, 5,000 metric tons of ore is blasted from the crust. About 1 ton yields just 12 grams of gold.
Taking out that amount of material rock creates an imbalance in the crust, which causes man-induced seismic events, mini earthquakes.
Around 100 a day, up to a magnitude 4. The miners aren't the only ones who find hidden treasure down here. In the depths of the mine, biochemist Esther van Heerden and her colleagues have discovered life. They call these tiny bacteria extremophiles. Some are an incredible 4/1000ths of a millimeter long. Almost 4 million would sit on the head of a pin. Theirs is a world without sunlight or oxygen. Home is 60-degree pressurized water up to 4 times saltier than the sea that collects between the rocks. This is the deepest scientists have ever found life on land. How the extremophile survive is unique. Radiation from the rocks breaks down minerals in the crust to provide nutrients.
We look at what food is available to them, and all of this gives us information trying to culture the bacteria and to understand what the parameters of life actually is.
The bacteria offer Van Heerden a window into conditions on early Earth billions of years ago. These bacteria could be the origins of life on Earth.
It's very much similar to what we would think primordial Earth would have been like. When we are down in the deep subsurface, we are kind of mimicking or seeing what we think at that stage was the start of life.
The Tautona mine is the furthest that man has ever explored into the rock layer that covers and protects our planet. Until now. Imagine we could take a journey along a tunnel that plots a course through Earth's crust. A rover would beam back images of a unique subterranean trip. It would circumnavigate the planet, traveling over 55,000 kilometers, visiting sites from South Africa to the Atlantic Ocean, and explore the diversity of the crust by burrowing through the rock just beneath our feet. The rover sets a northeasterly course. It leaves the African continent behind as it moves under the Indian Ocean. The rock now changes because Earth has 2 types of crust. A dense volcanic rock known as basalt forms the crust beneath the oceans. Earth's continents are largely granite rock.
If you imagine that this apple is dense ocean crust and this foam ball is buoyant continental crust, watch what happens when I put them into the mantle, which is the water. The apple bobs deeper into the water than the foam ball, which is why the ocean bed lies lower than the